So number 11 on the homework, it says when an unknown weight W is suspended from a spring with an unknown force constant K, okay, so both of those are unknown, it reaches its equilibrium position and the spring is stretched by a distance. So these are unknown. And then it's stretched by a distance. I'm going to go ahead and put X because I know people have different distances. So whatever X you have, that's the distance it's stretched by the weight when it's sitting there. All right, so it's originally not stretched at all, and then the weight is put on there, and it's stretched a distance of X. All right, so when the weight W is pulled down further, so when you pull this down, it actually gives you the distance, but in essence, it doesn't really matter what the distance is because it's going to oscillate up and down. And as it oscillates up and down, the amplitude doesn't matter. How much more it's pulled doesn't affect anything else in the problem. So it's released and causes an oscillation in the spring. So the question is to calculate the cyclical frequency of the resulting motion. So we're looking for the frequency. Frequency is our question mark. The acceleration due to gravity is 9.8 meters per second squared. So we got that value as well, 9.8 meters per second squared. Okay, so we're looking for frequency. If you remember frequency, the relationship between frequency is that it's 1 over the period. Also, another way of saying it is period is 1 over the frequency. And the reason I mention that is because on your equation sheet, you're not given an equation for frequency with a spring. You're given the equation for a period with a spring. All right, so once you find the period, you can take 1 over that to find the frequency. All right, so let's talk about period. Period of oscillation for a spring is going to be equal to 2 pi square root of m over k. All right, now m is unknown because we don't know the weight, and so is k. So these are both unknown values. All right, so let's think about this. How do I find m? Well, the weight is going to be equal to mass times gravity. So to find the mass, that's going to be equal to the weight over g. All right, so that gives me weight with respect to W and G that we know. All right, the next part, the spring force. So the spring force that's being pulled is going to be equal to the K value times X. All right, now keep something in mind here. The spring force is balancing the force of gravity when it's at this position right here, when it's at X. So at this point right here, the spring force is equal to mg. So mg is going to be equal to kx. All right, so what's interesting here is you can actually take k over to the other side. We get m over k, and then that's going to be equal to the x over g. All right, now with this right here, I come to realize that actually I have m over k within my equation over here. So that equals x over g. X is given to me in the problem. That's a known value here. G is 9.8 meters per second squared. So I can go ahead and plug that in up here, that the period of the spring will be equal to 2 pi square root of m over k. I accidentally rewrote that. 2 pi square root of m over k equals x over g. All right, so you can use this, and this is just for this instance, just for this case, where these values given, knowing this part right here. And when I realized actually this part is not necessary, I didn't need to do that, but I knew that there was some relationship at getting to mass. All right. Also, maybe it was useful to do it right there. All right, so we got m over k, which is in the problem. That equals the x over g. We can plug that in, get the period, and then once we take 1 over the period, that's going to give us our frequency. All right. Now, something to keep in mind is x is written in centimeters. It's got to be converted to meters. Make sure you get that. All right, so other than that, that should get you to where you need to go.